Doing a very important and a very interesting sum. Let's see this. It says that given is sides AB and BC and median AD of triangle ABC are respectively proportional to the sides PQ, QR and median PM of triangle PQR. Show that triangle ABC is similar to triangle PQR. Now here we need to understand, if you see there we had a word median twice coming, median AD and median PM. But first understand what is the median. Median is nothing but a line segment drawn from the vertex of a triangle to the midpoint of its opposite side. So that means we know here if AD is a median, that means D is a midpoint of BC, and if PM is a median, that means M is the midpoint of side QR. This is what we know in the sum. Now, the given information says that sides AB and BC and AD, that means AB, BC and AD of triangle ABC are respectively proportional to the sides, that is PQ, QR and median PM of triangle PQR. Now let's understand, what do you understand from this particular information, right? Understand now. When we say proportional, proportional means the ratios are equal. There are three ratios which are equal. Now how to write those ratios? I'll make you understand. It's very easy. What are we talking about first? AB, BC and AD of this triangle, right? So let's pick up only them, right? AB, BC and AD. They are proportional. That means they are proportional to what? PQ, QR and PM. That means they are saying that in short, AB upon PQ is equal to BC upon QR is equal to AD upon PM. This is what is given to us. So we have these three ratios to be equal given to us, right? And on the basis of this, we need to prove that triangle ABC is similar to triangle PQR. If you look at those two triangles, that is triangle ABC and triangle PQR. For these two triangles, we already have two ratios equal. The ratio of two corresponding sides, that is AB upon PQ is equal to BC upon QR in the given information. If somehow, if we can get that included angle, angle B is equal to angle Q, we'll get the triangles to be similar by SAS criteria. So our job is only to get that. Now let's get into that aspect of it. Let's observe. Now we already have one pair of elements, so we just need to find the other one. How do we get that? Now let's observe it. So this is something which we have. We're going to use this, right, to help us to get that. Now, if you look here, AB upon PQ is there, is equal to BC upon Q. Observe BC. For BC, what is D? D is a midpoint because AD is the median. So, what is the relation between BC and BD? We know that somehow we can say that BC is nothing but it is twice of BD. Why? Because AD is the median. Let's say this is my statement number 2. Same way, if you see QR, for QR, M is the midpoint. So what is the relation between QR and QM? We can say that QR is twice of QM, and that would be our statement number 3, and the reason would be because PM is the median, right? This is what we have. Let's do one thing. Let's substitute this in equation number 1. So we do that now. So we would get AB upon PQ is equal to, instead of BC we are going to write it as twice of BD, substituting that, and we write instead of QR we are writing twice of QM. Right, and that is equal to AD upon PM, and this is something which we got it from where? We got it from 1, 2 and 3, right? Now observe this very carefully here. 2 and 2 can get cancelled, and once we get 2 and 2 to be cancelled, what we have here is nothing but we'll have AB upon PQ is equal to BD upon QM is equal to AD upon PM. This is what we'll have. Now observe, but if you look at those AB, BD and AD, forget 2 is cancelled, AB, BD and AD, does it form one triangle? Yes, it forms one triangle, that is triangle ABD. Yes, and the other one, if you see PQ, QM and PM, do they form one triangle? Yes, they form one triangle, that is PQM. That means this will help us to get these two triangles to be similar. Let's see this now. So we're going to consider those two triangles in triangle ABD and triangle PQM. We know that AB upon PQ is equal to BD upon QM is equal to AD upon PM. Right, this is what we got from 4. That means now we say that these two triangles are they similar? Yes, they are similar. You know by which criterion? Yes, they are similar to each other by SSN similarity criterion. So we write that the triangles are similar to each other by SSS similarity criterion. But why did we do this? We wanted that angle B equal to angle Q. Now can we say that? Yes, we'll get it. So that means now we can say angle B is equal to angle Q. You know why? Because they are the corresponding angles of similar triangles, and that happens to be our statement number 5. Is this going to help us to prove triangle ABC similar to triangle PQR? Yes, let's do that now. So we consider now that two triangles in triangle ABC and triangle PQR. We know those two ratios which we had taken, that is AB upon PQ is equal to BC upon QR. It is already known to us, right, because we were given that, right, from 1, and that we have the included angle, that is angle B equal to angle Q. We got it from statement number 5. So now we say that these two triangles, that is triangle ABC and triangle PQR, are they similar to each other? But you know by which criterion? Yes, they are equal. They are similar to each other by SAS criterion. And therefore we write the last statement, therefore triangle ABC is similar to triangle PQR by SAS similarity criterion. Now we got the sum. Wasn't this easy? A very, very, very important sum.